Okay, so we're gonna start talking about arcs. Arc is basically the distance outside of a circle. So for example, I could call this arc right here. I know we talked about arcs before. Remember arc length? We found out what's the length of an arc. So basically if I had a circle and I had a string, I could measure the length, with a string. But that was before. Today we're going to be talking about the measurement in degrees. I know we have used degrees for angles before, but now we're going to be talking about arcs. They also have degrees. Let me use a circle here. Let me do an example here. Let's assume that's a circle. Now the circle has a center, right? There's a center in there. Now the interesting part is that any angle inside, right, in the center of the circle. Let me do this angle here. I'm gonna use this letter, this Greek letter called theta. Theta basically means measurements over whatever the degrees of that angle in the center is. We're gonna call this the central angle, okay? Because it's the angle in the center of the circle. Whatever degrees that central angle is, the same degrees is the arc that the angle creates. Okay, so we see in blue, we see the angle, right? You guys see the angle in the center of the circle. And I'm gonna say that is theta degrees, right? Any degrees. Now that angle creates this arc. I'm gonna do the arc in red so you guys can see. That angle creates that arc, and I'm gonna say this arc also has theta degrees. Okay, again, theta is any number that we want. But what I'm going here is the central angle, the degrees of the central angle, it is the same amount of degrees of the arc that it creates. Okay, big rule. Now, how are you gonna name arcs? Let's just say that I had a few points here. Let's say I have 4 points, and I'm gonna call this points, let's see, A, B, C, and D. Okay. Now, the way we're gonna be labeling our arcs, I'm gonna use at least two letters. Let's say I say the arc AD. Basically, I'm gonna go from A to D. When I use two letters, I'm gonna go the shortest way possible. Okay. If you guys think about it, it is like, well, Mr. Leonzo, I could have gone from A to D. I could have gone this way, or I could have gone from A. I could have gone this way. Right? Those are two different arcs. But when I use only two letters, we go the shortest way possible. In this case, see how I highlighted one arc in yellow and then the other one in green? In this case, it would be the yellow arc. Again, when I use two letters, I go the shortest way possible. Now, the green arc, if I wanted you guys to use the big arc, I would have said from A to D, but then I'm going to put a letter that is in between them, right in between A and D. So if I would have used three letters, now that one we're gonna call the grade arc. So I would have say the arc ABD. So I still want you to go from A to D. However, I want you to pass through B in between. So start at A, pass through B, and go to D. So usually when we use two letters, it's a short arc, it's a small arc. When we use three letters, it's a big arc. So you guys are going to be looking at those, okay? So remember how I said earlier that the measurement of the angle, the central angle, it is equal to the arc that it creates. All right, so let's take a look at here. We're going to find the measure of the arc or central angle indicated. Notice how for question number 1 and 4, when you guys read this, number 1 and 4, I'm asking for a measurement of an angle. For number 1, I'm asking for the measurement of angle LIN. For number 4, I'm asking for the measurement of angle ECG. So look, sometimes I can ask for an angle. However, sometimes I may be asking for an arc. Look at question number 2. I'm asking for the measurement of arc VR. I'm using two letters, right? So I expect that arc to be a small arc. But look at number 3. I'm asking for the measurement of arc KGI. I'm using 3 letters. So I'm expecting that arc to be a big arc. Okay, so I could be asking for an angle, I could be asking for an arc. So that's what it says. Find the measure of the arc or central angle indicated. Question number 1, it will be an angle. Now let's assume that lines which appear to be diameters are actual diameter. So if it looks like a line crosses through the center, but it crosses the whole circle, we're going to call that a diameter. Where do I see a diameter? Well, here. I'm going to show you guys. Let's assume that is actual diameter. I can see another diameter here. But now in blue, I'm not going to call this a diameter, right? That's only a radius. So remember, the lines that appear to be diameter are actual diameter. Okay, so we're looking for the measurement of angle LIN. So if you guys connect the points L, I, and N, that has to give us something, right? So here's the point L, here's the point I, here's the point N. So I'm looking for this angle. Now that angle creates this arc. If I knew the arc, then I would know the angle, right? Because it's the same thing. Now I see part of the angle or part of the arc is 74. From L to M, the arc LM is 74. Let me highlight. The arc LM is 74. Now it would be nice if I knew the arc MN. Okay. Now, want you to focus. Let me take this out. Want you to focus on this angle. Pretty sure we can figure it out. We can figure that one out. Let me just point out we have a diameter here. So that means this whole thing. So I'm going to say this arc and this arc combined is 180. Remember, a diameter cuts the arc in half, or the circle in half. The whole circle is 360. So wouldn't the half be 180? I see this part is 119, right? You guys see the angle in there? So I'm going to say this arc right here is 61 degrees. Because combined, it has to be 180. Remember, I'm looking for diameters do help me out. Because the angle of a diameter, I remember back in semester 1, we talk about the angle of a line. The angle of a line was 180. So here, the angle of a segment obviously has to be 180. Part of it was 119, so the other part has to be 61. Again, combined has to be 180. So, okay. So coming back to the angle that I needed, let me erase a few things here. Let's go in blue. I'm looking for this angle, right? LIN. I'm looking for this angle. And I said it is equal to this arc. Part of my arc is 74. I'm going to highlight it again. This is 74. The other part is 61 because we just figured that that was 61. So how big is the whole arc? 74 and 61 combined. I'm just going to add them. 74 plus 61. So I'm going to say this is equal to the measurement of angle LIN. It is equal to 135. What you have to do is take a look at what you have. I saw we had a 74. I saw we had 119. I saw we had diameters. So take a look at what you have. Take also a look at what you're looking for. And then figure the missing numbers. Okay, let's take a look at question number 2. I'm asking for the measurement of arc VR. So from V, go to R, the shortest way possible. So I'm looking for this arc. Okay. It would be nice if I knew this angle because they're the same length. If I knew the angle, then I would know the arc. Okay. I see a number 50 there, and I'm like, we should be able to use that. Probably if I could find a diameter as well. Here's a diameter. The reason why I want a diameter is because the angle of a line, so the one side, it is equal to 180. Okay, so I see part of it is 50. So I'm going to say this other angle here is 130. Remember, the angle of a diameter is 180. So if part of it was 50, the other part is 130 because combined is 180. So that tells me this arc right here, it is 130. Remember, the measurement of the central angle, it is equal to the arc that it makes. You're like, the arc that it makes? Okay, well, take a look at the angle. This angle makes this arc. So that's why I said the central angle, the degrees of the central angle are equal to the degrees of the arc that it creates. So the measurement of the arc VR, I'm going to say is equal to 130. Okay, not bad. Let's take a look at question number 3. I'm asking for the measurement of the arc KGI. So I want you to go from K to I, but I want you to go through G in between. So I see K here, I see I here, and I see G here. So remember, I'm going from K to I, but G has to be in between. So that means I'm asking for this arc. Okay. So I see part of it is 68. That's great. Let's do with blue what I need. I see this part is 68. I would need this part and kg as well. Combine, right? There's 3 pieces. I could add them all up. So I remember one rule. I remember one rule that we saw before, but I remember I mentioned, we saw this back in semester 1, vertical angle theorem. And I said that's a very, very important rule. And I remember I said the vertical angle theorem, whenever we see an x, the angle from one side is equal to the angle on the other side. So I see an x here. You guys see that x. So one side is 68 degrees. So I'm gonna say, well, guess what? This other part right here, it is 68 degrees as well. Okay, so I'm just trying to complete measurements that I know. Then I know a diameter. A diameter cuts the whole angle of a diameter is 180. So I see a diameter here. So I'm gonna say this whole thing is 180. Part of it is 68, right? So I'm thinking, okay, 180 minus 68 is 112. So I have to break these two angles. These two angles combined have to equal to 112. Now I see that they're both marked the same way, right? You guys see they both have an arc. So that means they're the same number, right? When I mark them the same, that means they're the same number. Okay, so if they have to add up to 112, for me to know how much each of them are, I'm gonna go 112 divided by 2. So that tells me each of them is 56. So I know this angle is 56, this angle is 56, and if I wanted to know this angle, I know 68. Remember, all 3 combined, if you guys don't believe me, add them all 3, and it should give you 180, right? Because it's the angle of a line. Okay, so I know this arc right here, it is 56, and I know this arc right here, it is 56. Okay. Now you guys might be wondering, why are you getting information that you don't need? Because at the end, we're looking for, let me highlight in green, we're looking for this arc. So far I know part of it is 68, part of it is 56, and I need to figure the other part. Now there's a few ways how we can do this. There's a few ways. I can use vertical angle theorem to find out what the arc KG is. And let's see, vertical angle theorem. Let me look at an X here. This arc right here, it is 112. So I'm gonna say this angle right here, it is 112. Remember vertical angle theorem, when there's an X, opposite angles are equal to each other. So this is 112. Nice. I think I have enough, right? I have enough to figure what that is. So I'm just gonna add them up. 112 plus 68 plus 56. So I'm gonna say this is equal to 236. The arc KGI is equal to 236. Now let me show you one more thing. Let me erase this. The beauty of mathematics is that we can figure our answer sometimes more than one way. Let me highlight this arc in yellow. Let me highlight that. Okay. How much is 68 plus 56? And I'm looking at that yellow arc is 68 plus 56. I'm going to say, well, that's 124. Okay. So this is 124. Okay. How can I figure out from the yellow arc? The yellow arc is 124. How can I figure that the green arc is 236? Well, remember how the whole circle is 360? Well, so just go 360 minus 124, and you can figure that the green arc is 236. Because combined, it has to be 360. Nice. Now, that was a different way how to do this. You're gonna find that you can come up with your answer more than one way. But always say mathematics is the way you go from a place to your home. You have a home, right? You go to a place, but you can take many ways to get there. Same thing with math. So let's take a look. Here I'm asking for the measurement of the angle ECG. So if I connect E with C with G, so I see here's E, here's C, and here's G. So if I go in that order, ECG gives me that angle, which is equal to this arc. Okay, I know part of the arc is 90, but I don't know how big is all of them. Now, one really cool thing is that I can figure out how big is this blue arc. You see the blue arc, part of it is 70, part of it is 66, part of it is 93. Some of you might be thinking, Mr. Leon, so 66 and 93 are arcs. 70 is an angle. But remember how I said earlier, the central angle, it is equal to the arc that it creates. So that means the arc GH is 70. So it doesn't matter if the number was given to me as a central angle or the number was given to me as an arc. The same thing. So I'm gonna say the blue arc, right? I can always add 70 plus 66 plus 93. I'm gonna say the blue arc is 229, right? I just added those three numbers. So I can find out how big is this red arc. Right now, let me call it X. Okay, can you figure out? The red arc is X, which is the answer. That's what we want. The blue arc is 229. Well, combined is 360, right? So I will go 360 minus 229. So it gives me that this arc is 131. Okay, that's my answer. Nice. Remember, this the angle in the center, the central angle is equal to the arc that it creates.